Good evening, everyone. Welcome to Unacademy. Welcome to the session. So, let's start the session today. So, am I audible to everyone? Please comment. मैं तो आज एक नया माइक लाया, so टेस्ट कर रहा हूँ. माइक सही से काम कर रहा है नहीं कर रहा है, आप बताओ. Is it everything fine, Vandana? Right. So, आज का क्लास में हम क्या डिस्कस करना चाहिए? The problems on sequential circuits. Actually, last few days my mic there is some issue with my mic. Some people also commented in the videos. Now the audio is fine quality. Everything is good. Thank you. Okay, just 2 minutes, please. Okay. Now we right. So let's start. आज का क्लास तो है लास्ट फ्यू लेक्चर्स में मैं तो सीक्वेंशियल सर्क्यूट्स खत्म किया. लास्ट 3 लेक्चर्स में फ्लिप फ्लॉप्स, रजिस्टर्स, काउंटर्स तो डिस्कस किया. आज के क्लास में वी आर गोइंग टू डिस्कस ऑल द प्रॉब्लम्स ऑफ द सीक्वेंशियल सर्क्यूट्स. सो ये प्रॉब्लम सॉल्व करने के पहले सो लेट मी गिव यू एन इंपॉर्टेंट अपडेट रिगार्डिंग अनअकैडमी का रिपब्लिक डे ऑफर गोइंग ऑन राइट नाउ. सो दिस ऑफर इज गिविंग यू ऑलमोस्ट 30% discount on an academy subscription by using the code Shankar10. So how to save almost 30% is the price is going to hike from next week. I mean, I don't know the exact date, but these are the new prices going to hike. So अभी तो आपने code apply किया तो you get 20% discount on this, and the new price also, if you consider, almost you are saving around 27% on your subscription prices. So 1 year subscription will come out to you as low as what is that, 31,000. Okay, compared to the regular fees of this much 39,265, you just pay need to pay is almost you will be saving 30,000 compared to the next hike prices. Okay, so the new batches also started, guys. If you want to take the subscription, you can start the subscription. These are our rankers this year from GATE ESE examination of electrical and ECE engineering, and this is the new batch started recently, that is Udan and Bunyad batch for 24-25 aspirants. I have started signals and system in the morning batch, morning 7 to 9 a.m. we are discussing this. You can join this and continue your preparation if you are 24-25 aspirants. इसमें आपको सभी benefits मिलेगा, जैसा plus subscription पे you will be getting the classes by the top educators and regular notes मिलेगा, doubt solving sessions मिलेगा, DPP, all PYQs will be solved in these sessions. Okay, so and also we have the batch for IRMS examination. If you are aiming for IRMS examination, GATE and UPSC IRMS का combo आप ले सकते हैं, and इसमें भी you can take the subscription using my code to save the maximum. Okay, thank you. Then you have the last chance to enroll to this AMT examination. Yeah, don't miss this. This is the last exam you are having before writing the original examination. Give a try and check your performance compulsory. Okay, and this exam, the questions are made by the top educators of an academy. You get, based on your ranking, you will be getting the scholarship up to 100%. So let's do sequential circuits. Okay, sequential circuits, इसमें we will be solving the problems now. Okay, Utkarsh, when is the exam year? बताओ, then we can plan something. यूपीपीएससीएल के लिए एग्जाम कब, ये सभी डिटेल्स दे दो मेरे को। सो लास्ट लेक्चर मैंने मॉड 8 सिंक्रोनस काउंटर को आपको एक्सप्लेन किया। सो अभी हम क्या करना, एक अच्छी तरफ से मॉड 16 वाला काउंटर डिस्कशन करना चाहिए। देन इसके बाद आई विल टेल यू हाउ टू डिजाइन एनी सिंक्रोनस एंड देन वी स्टार्ट डूइंग द प्रॉब्लम्स how to analyze any synchronous counter. Okay, we start the problems after the discussion of this, right? Chill. So okay, see here. So this is the mod 16 synchronous up counter. I will explain this, then we will do problems. This is the only concept left over in the synchronous circuits. After that we do the problems. Here clock is applied to all flip-flops simultaneously, so there is no problem at all. So when here, because both the inputs are 1, Q0 toggles on every clock pulse. So if you take Q3, Q2, Q1, Q0, this will toggle. Initially you take all zeros. It will toggle on every clock pulse like this. Then what about Q1 sir? Q1 ka input is nothing but Q0. When Q0 is 0, you get no change, 0, 0. When it is 1, that is not sufficient. Because here this is not the clock. Clock is to be given for the change. So when it is 1 and clock is applied, it will toggle. So when Q0 is 1, in the next clock pulse, it will toggle. When Q0 is 1, next clock pulse, it will toggle. Q0 is 1, next clock pulse, it will toggle. Q0 is 1, next clock pulse, it will toggle. Okay, Q0 1, next clock pulse, it will toggle. Similarly, Q1 and Q2 together are given here. So when both are equal to 1, in the next clock pulse, this will toggle. Because it is both J3, K3 are connected to this. When both are 1s, next clock pulse, this will toggle. Next. When all the 3 are 1s, next clock pulse, this will toggle. And this process continues. We are not writing here every single possible step. So up to 12 I have given. So it will count up to 16, 0 to 15 it will count. So like that it will count to mod 16, count from 0 to 15. Here if you calculate the total delay is equal to, once input is to be ready, input के लिए 2 gate delays, 2 gate delays plus once input is ready, then we apply the clock, all flip-flops change at the same time, 1 flip-flop delay. You can say here n minus 2 times gate delay. Why? Because the first 2 states may no delay, after that 2 gates na plus TF. You can also do like this. You take Q1, Q0 na. Instead of taking output of this as input to this, take all the 3 inputs to the AND gate directly. इस केस में क्या होता है सर, 1 gate delay पे काम हो पाएगा. Here what happens, if this gate output is given to this na, 2 gate delays it is taking. But here if you take directly this Q1, Q0 and 3 input gate here, 1 gate delay पे हो जाएगा. In that case the total delay will be 1 gate delay plus 1 TF. Sometimes the time period of the clock must be greater than T setup, that is to make the input ready, I mean TG, and to read the input setup time plus TF. So the frequency of the clock should be less than 1 by T setup TG plus TF. If examiner don't give setup time, neglect it. This is F maximum approximately equal to 1 by T of the flip-flop. There 1 by NTF, this is 1 by TF. Here N times speed improvement. So here always, I'll do it in the problems, when you analyze any synchronous counter, because the clock is applied, by the time you are applying the clock, input is present, na, that is will be giving the output. Because once you apply clock, na, input changes. Because this output changes, it will affect the input. That input should not be affecting this here. Because when you apply the clock, उस समय पे already existing जो होते हैं ना, that only matters. So to make analysis easy, we always analyze the synchronous circuit from the right hand side, because it will avoid confusion. For example, initially you have 111, 0, 111. Now the process is, first your input is to be made ready, that is read the input. 1 into 1, what is the answer? 1. 1 into 1, what is the answer? 1. So 2 gate delays are required for this. Once input is ready, apply the clock. Then what is the output you will get? Read from here, you will be confused. Read from here. What is the input? Just a moment. Existing is 0. Now see here, yeah. When you apply the clock, this 1 will appear here. This 1, because of the JK flip-flop, it is in the toggle mode. 1 into 1 will give me toggle of previous. Previous toggle क्या होता है sir? 0. Here 1 1 previous toggle 0. 1 1 previous toggle 0. Because if you don't analyze in this way, then 0 111 7 next state is 8, clear. But if you analyze from this side, na, this 1 changes to 0, you confuse whether 1 is to be taken as the input, 0 is to be taken as the input. Always, by the time you are applying the clock, what is the existing, that is to be considered as the input. After applying the clock, if input changes, it should affect in the next clock pulse, not immediately. So to analyze any synchronous counter or synchronous circuit, to avoid confusion, always analyze from the rightmost flip-flop. By the time we are applying the input, by the time we are applying clock, already existing input will give the output. After clock, अगर input change हुआ तो it will not reflect in the same clock, it will reflect in the next clock. Only one change in one clock pulse. ठीक है? चलो. That's all. Okay, about the theory. Now let me do one question first, then we will do many number of questions. So the first question here. Design a synchronous counter which counts the sequence zero 3 1 2 0. Okay, so I will show you the process to design any synchronous circuit. Chalo, first we should make one table. Here we should write present state next state, and what are the inputs to be applied. This is the table we should follow. In the present state, firstly here it is a mod 4 counter because it is having 4 states. So log to the base 2 4, you take 2 flip flop. You can take any flip flop of your choice, JK flip flop, SR flip flop, कोई भी flip flop ले सकते. मैं तो D flip flop ले रहा हूँ. Okay. So present state में Q1 Q0, next state Q1 Q0. So here what we do is, in the present state, fill all the possibilities. All the possibilities means 0 0 0 1 1 0 1 1. In the next state, fill your requirement. आपको next क्या चाहिए सर? 0 के बाद 3, 1 के बाद 2, 2 के बाद according to examiner requirement 0, 3 के बाद examiner requirement का हिसाब से 1. डी फ्लिप फ्लॉप का एक्साइटेशन टेबल, हमेशा इनपुट का मतलब क्या? एक्साइटेशन टेबल. सो अकॉर्डिंग टू Qn plus 1, what are the inputs to be given to the D flip flop? Excitation table of D flip flop is nothing but आपको नेक्स्ट में क्या चाहिए तो वो इनपुट में देना चाहिए. सो हियर दिस विल बी गिवन टू द इनपुट एज यूजुअल. ठीक है भाई, चलो हो गया काम. नाउ if you solve this by K-map भी नहीं चाहिए दो वेरिएबल के लिए. K-map क्यों? What is your D1? It is Q1 bar Q0 bar plus Q1 bar Q0. Q1 bar D0 Q1 bar Q0 bar plus Q1 Q0. Q1 exclusive NOR with Q0. ठीक है. So take 2 flip flops. With a common clock. This is how you are going to design a counter. So here it will be Q1 bar. Here this will be Q1 and Q0 का XNOR operation. बस. That is about your design. ठीक है. Let's proceed further. चलो, let's discuss now all the problems based on this. For any synchronous design, this is the process. Presently, what is your state? Write all possibilities. Next, आपको क्या चाहिए according to the required condition. Then, what are the inputs to be applied? There are some cases. Suppose here 2 flip flops are there, 4 states are there. मैं तो सारे states use किया तो ठीक है. Suppose only 3 states are used. Unused state comes. Next state generally we take, don't care. If you don't care and design it, our sequence, if by chance enters into unused state, it should come back to the used states. If it is not coming back to used, and by chance if it is continuing in the unused states only, then it is called as a lockout problem. Then we should restart the system. Otherwise, if we design like that, if unused state comes also, next state is used state only, then it is called as what we call self-starting counter, no lockout. Generally, suppose we use only 3 states, 4th state is not used, for example, then that 4th state, next state, you should take any of the used states, such that even that occurs also, there will not be any problem in the response. Okay. Chalo, now let's solve the questions one by one. चलो भाई फर्स्ट क्वेश्चन तो शुरू हो रहा है, आप लोग तो तैयार ट्राई करना चाहिए कंपलसरी। ओके कंपलसरी आंसर करो। सी प्रेजेंट स्टेट 0, next state is 1, 1 का next state 2, 2 का next state 3, 3 का next state 3. Here the counter after 3 not coming back to 0 or going back to 0. It will continue or stop at 3 only. Saturating counter. Normal counter mein it will after 3 it will go back to 0 and it will repeat the same. Here it is not repeating. After 3 it stops. Okay, see, let us find how many, how to design this. Next state. Give a try. Nobody is answering. Please try. Time up. It's the same choice, but only last it changes. So here, let's design present state, next state, the inputs. So present state Q1, Q0, next state Q1, Q0. What are the inputs? T1, T0. So the present state here, you take all the possibilities 0, 1, 2, 3. In the next state, it is 1, 2, 3, and 3 can state also 3. So for T flip-flop, what is the excitation table? If the present state, next state are same, give 0. If present state, next state are different, you should give 1. So present state, next state are same, 0, different, you give 1. Different, you give 1, same, different, you give 1. Same, 0, present, next, different, 1. Bit by bit you check. Same. So what is your T1 here? Q1 bar Q0. Only 1. T0, it is only 1 0 na. Write SO instead of SOP, write POS, it is easy. Q1 bar plus Q0 bar. I think some mistake is done, but right. So this T0 Q1 bar plus Q0 bar, T1 Q1 bar Q0. Option B is the right answer. Okay, चलो let's move for the next question. अरे यार आप लोग पार्टिसिपेट करना चाहिए एक्टिवली इन द क्लास. सो दिस इज गेट 2021 इलेक्ट्रिकल इंजीनियरिंग का क्वेश्चन पेपर का क्वेश्चन है. So please try this also. राइट चलो टाइम अप. Here firstly examiner ka, see first here also make a table. Present state, okay, next state, inputs, okay, D2, D1, D0, Q2, Q1, Q0, Q2, Q1, Q0. So the present state, you can take all zeros to all ones. First all possibilities we should write, okay? All zeros to all ones. Now the next state here, what could be the next state is according to the given condition by the examiner. Examiner 0 का next state क्या दिया? 0 0 1. Examiner ने दिया 0 का next state 0 0 1 and 1 का next state 0 1 1, 2 का next state 1 1 0, 3 का next state 0 1 0, 4 का next state 0 0 0, 5 का next state 4, I am writing from here. Next 6 का next state 7, 7 का next state 5. Okay, then what are the inputs you should apply? Inputs we should apply is for D flip flop, whatever you want in the next state, the same to be given as the input. Whatever you want in the next state, the same to be given as the input. Now see here, I can say what is the examiner ka question for D1. So D1 का K map draw करो, Q2, Q1, Q0, D1 का K map 0 1 1 0 0 1 0. This will make a pair and this will make a pair, and the D1 is equal to Q2 bar Q0, Q1 Q0 bar, Q2 bar Q0 plus Q1 Q0 bar, Q2 bar Q0 plus Q1 Q0 bar. Option A is the right answer. Anybody here? Yes, correct, Vandana. So option A is the right answer. So this is how you need, this is the electrical paper ka question hai. So this is how you are going to design any synchronous design given by the examiner. Right, next question. Don't think this is very complex. If you read the question, it is very simple. First read it, then it is not, you don't feel any difficulty. I am giving you 1 minute of time, so please give a try. Please give a try, you can definitely do it. Right. Time up. No answer. Nobody gave any answer. What happened? The state transition diagram for a sequence generator. It is generating the sequence of 5 to 6. Okay, present state 5 hai to next state is 2, next state 2 connect state 6, 6 connect state 5. It is designed that the D flip flops and the combinational blocks L1, L2 and L3 are initialized at Q2 equal to 1, 0, 1. Okay, initially it is 1, 0, 1. Okay, next state is what? This is O means output. That is the input you should give to the D flip flops. Okay. Initially it is 101. Next you require 110. Next require is 111. Okay. So you need to find the minimized expression for it. Here. Present state, next state and inputs. Okay. So the present state is 0. It can be all possibilities. What could be the next state here? Next state is 0 is not given, 1 is not given, 2 is given, 2 connect state 6, right? Next, 3 not given, 4 not given, 5 is given, 5 connect state 2, and 6 not given, 6 is given, 6 connect state is 5, 7 not given. So in fact D2 is nothing but the same because he used the D flip flop. A characteristic equation or excitation table is same as whatever you have given in the Qn plus 1. Right now this is D2, this is nothing but your O2, O1, O0 as per examiner. Okay, so let's take one. Okay, D2, D1, D0. Okay, see here, the D2 is double X 1x, double x, x0, 1x, d1 double x, 1x, x1, 0x, d0 double x, 0x, then x0, 1x, right? So this will be one quad which will give you d2 equal to q1. ये भी एक क्वाड है, ये भी एक क्वाड है, सो d1 इज इक्वल टू एक क्वाड का q1 बार और q2 बार, ठीक है। d नॉट क्या होता है सर? d नॉट इज इक्वल टू ए सिंपल पेयर, that is q1 here, q2 q1, so d naught is equal to q2 q1, okay. q naught नन क्यों आ रहा है? d2 is q2, correct. इक्वेशन तो सही है यार, हाँ, मे बी हियर बार इज नॉट प्रिंटेड. q1 बार, ये दोनों सही से दिया. दिस इज करेक्ट, दिस इज ऑल्सो करेक्ट. ये गलत क्यों आया? q2 बार ओनली, q1 बार, दिस इज q1 बार लेना. नन तो है बट आई एम स्मॉल चेंज किया मैंने, ठीक है. चलो, ऐसा कुछ नहीं है ना, मैं गलत तो क्यों नॉट क्यों बार. Yes, this is also correct. He has taken this pair. See here, second one is double x, 1x, x1, 0x ना. He has taken this pair. I have taken this squared, he has taken this. दोनों आंसर देती है ना. So what is your d1? q2 bar plus q0 according to examiner, option C. Okay, चलो. नेक्स्ट क्वेश्चन. सो अभी तक हमने क्या किया? डिजाइन किया. डिजाइन का मतलब क्या? अभी तक हमने जो क्वेश्चंस देखा, एग्जामिनर इज इन द रिक्वायरमेंट ऑफ वन पर्टिकुलर सीक्वेंस, वी हैव डन दैट पर्टिकुलर सीक्वेंस, वी हैव इंप्लीमेंटेड दैट पर्टिकुलर सीक्वेंस, वी हैव डिजाइन्ड इट. नाउ दिस इज द क्वेश्चन ऑफ एनालिसिस. If examiner has given you the figure, he want you to analyze the things, you want to write the expression, how to do it. Let's see. So please try. I will anyway explain it. Time out. Any answer? Options? Okay, no worry. See, one method is you can directly analyze from the circuit, but it requires more time and patience that will waste your time. So don't analyze that directly from the circuit. Another method is you can write the characteristic equation of the system. What is Qn plus 1 JQn bar plus K bar Qn? From this, for Q1, what is the next state and what is the next state of Q0? Let us see. For Q0, J0 Q0 bar. J0 is nothing but Q1 bar. Q0 bar plus K is equal to 1. So 1 bar into Q0. So Q1 plus Q0 whole bar. Similarly, for Q1, what is the next state is? What is its J input? Q0. JQn bar plus K bar. K is how much? Q bar whole bar into this will give me Q0. So present Q0 Q1. What will be the next? Next state is equal to Q1 plus Q0 whole bar and also Q0 will be the next states. So here you take presently initial start. Here don't take all possibilities because you don't know how many states it is going. First initially start with 0 0 because he has given this. Next is here don't take all possibilities. Here we are doing analysis, not the design. Already existing को analyze कर रहा हूँ. So don't take the table of present, next and inputs. Here present state ले लो. Next state हम analyze करना चाहिए from the given equation. So Q1 plus Q0 whole bar will give you 1. Q0 will give me 0. So this is the next state now. So Q1 plus Q0 whole bar is 0. Q0 1. 0 plus 1 1 whole bar is 0 1 ले लो. Then 0 plus 1 1 whole bar is equal to 0 and Q0 is equal to 0. So we started with 0 0, ended with 0 0. This is an example of mod 3 counter. This is a fastest possible way of solving the question. But if you are not convenient with this, I'll give you easiest way to do the question. Easiest way to do the question for analysis is, this is the process. Present state what are the inputs according to the design given from the figure, that is J0, K0, J1, K1. What will be the next state? So if you see J0 and K0, J0, K0 तो 1 है and Q1 bar. So Q1 bar and 1. J1, K1, Q0, Q0 bar. Ready. Now as easily as possible we are doing the analysis. So start with 0 0. What are the inputs you will get to the flip flops? Flip flop का अंदर क्या कौन सा input चलेगा सर? 0 Q1 bar, Q0 bar. So when you give 1 1, when you give 1 1, this will toggle. When you give 0, so what are the inputs you are giving? 0 1, 0 1 means it will be 0. These are the inputs for the flip flop. This is the output you will be getting it. So present state 0 0, next state is 1 0. You give 1 0 here. Q1 bar 1, Q0 bar. So Q0 and Q, what is this? 1 1 is given, previous ka complement. 1 0 is given, 1 will come. So the next state is 0 1. This is the standard form you can do for any synchronous circuit ka analysis. So here Q1 bar 0 and Q0. So it will both 0. Finally it is a mod 3 counter. Examiner, see here, clock 0 1 2 3. What is the output you will be getting? 0 0 1 0 0 1 00. It is repeating now 4 5 6 and so on. 28 29 30 31 32 33, right? Okay, so first clock, second clock, third clock. So 33 clock pulse ke baad what is the output is asked by the examiner. Instead of doing this, you can also do like this. You do 33 mod operation with 3. Mod operation will give you remainder of the division. Iska remainder kya hota hai? 33 mod 3 pe remainder is 0. So 0 clock is equivalent to 33 clock. 0 clock mein what is the answer? 0 0. For example, examiner asks you 724 clock ka output kya? 724 you divide with mod of the counter. What is the mod? Because it repeats after every 3 clock pulses. So what is the remainder of this division is 1. So clock 1 and 724 clock are same. So what is the output you get after the first clock according to our analysis? 1 0 is the answer. Right? That is how you can find the output for any clock after finding the mod. To find the mod or the response of the system, this is the table of analysis. That is present state, input, what will be the next state. Today जितना भी problems possible है तो उतना कर सकते हैं अभी. इसके बाद day after tomorrow we will be starting data converters. ठीक है, tomorrow, day after tomorrow I will finish your syllabus. As per my promise, I am doing it on time. चलो भाई, next question. This is a beautiful question. If you are able to do it, it is really appreciable. Please give a try. Please give a try. Okay. To analyze any sequential circuit shown in the figure, say, analyze the sequential. So firstly, what is this? QA, QB, so this is your QA, QB bar, X bar, this is QB bar, so QB bar, QA bar, that can be written as QB plus QA whole bar, right? So what is this input? QA plus QB bar X bar, this input QB. It is highly impossible to analyze this circuit directly from the figure. It will take a lot of time. So to analyze it easily, we take the help of whatever the table I have explained earlier, that particular method. QA into X. Right. Here also take the table present state what are the inputs? J, he asked in the order of J, A, K, A. Okay, 1 minute. J, A. What is the input J? Q, A, X plus Q, B bar X. K, A, it is Q, B. JB, 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 QA, KB, QB plus QA whole bar. What is the next state? So initially we start with 0, 0. Initially we start with 0, 0. So already there is no use of figure now. Already I have taken that equation. So QA 0 into X plus 0 bar into X 0, 0, 0. Actually last one might be, this is X bar na? X bar. Right. So your KB equal to QA plus X whole bar. So QA is 0 plus X whole bar. So what are the inputs you will be getting? It is here 0 into anything is 0, 0 bar is 1, 1 into X, X 0, 0, X bar. Right, here bar, X bar, X bar. So here if X equal to 0, you get 1, 0. If X equal to 1, you get 0, 0, 0, 0. No change. It is not required because according to the question, the output should change from 0, 0 to 1, 1. Isliye if you give X equal to 1, it will not work. So compulsory give X equal to 0. Then 0 bar is 1, 0, 0, 0 bar is 1. So what is the output you get is 1, 0. So we started with 0, 0. We end with 1, 0. So listen carefully. Okay, so present state is 0, 0, next state will be 1, 0 if you give X equal to 0. Don't give X equal to 1. So then 1, 0 is given. So QA is 1 into X, 0 into X bar, 0, 1, 1 plus X whole bar. Here X plus X bar 1, 0, 1, 0. it is independent of x. Second case may x can be any value. What is the output you get is 1 1 because the input is 1 0. So what are the required condition to achieve 1 1 from 0 0? First you should give x equal to 0. Second you should give x equal to any value, that is either 0 or 1. That is, you can give 0 0 and 0 1. Both the cases this can be achieved. That is, which one is available in the option? 0 0 is available in the options. Okay, so state 0 0 to state 1 अचीव करने के लिए x की जगह पे हम क्या देना? First you should give 0, second clock में you should give anything, no problem. Right? चलो, let's go for the next question. So this is the question of the previous paper only. Next question. Timer. Any answer by anybody? I'll wait for a few more seconds. Okay, fine, no problem. You have a 3-bit gray counter. It is connected. So here when a naught equal to 0, enable bar will be 0 and this will give you the output based on your S1 and S naught. But when e bar is 1, because it is pull to, by default the output will be equal to 1. So let's take A2, A1, A naught. So those are connected to, A2 is connected to S1, A1 is connected to S0, A0 is connected to E bar. What is the gray count? It is first 0 1, mirror image 0 0 1 1. Unit distance code. Here 4 zeros you should take. And here mirror image again. And 4 ones. This is called the gray code. So you see, in electrical engineering syllabus, they have not given number systems, but they have asked questions based on the gray count counter. In 2021, they have given the question, right? This one, but he has specified that sequence. Generally, in number systems, we discuss how to generate the gray code. This is the shortcut to generate the gray code. You take 0 1, उल्टा ले लो, then दो 0 2 1 ले लो, इसका उल्टा ले लो, 4 0 4 1 ले लो. Now, firstly, tell me here, when E bar is 0, what is your output? E bar 0 वाला ले लो. When E bar is 0, it will give you this one according to the input. 0 0 means I naught, 0 1 means I1, I3, I2. Otherwise, what it will give? When it is 1, it will give, it is disabled, and it is because it is connected to by default 1, you get 1, right? Right. So see here, so this is the output sequence. I naught, though 1, I1, I3, though 1, I2. Right? Chalo, let's move further. चलो नेक्स्ट क्वेश्चन पर. So this is a sort of question based on the counters. Okay. Please try. It may take time to read the question. Further, the control signal function of a 4-bit counter are given below, where X is the don't care. Okay. So when clear input is 1, clock can be applied, load can be applied, count can be applied or not, doesn't matter, it will immediately clear. Clear is the high priority here in this. Then clear के बाद क्या? When clear is 0, clock is not applied, then when load and count also not applied, it will not do anything, it will keep in the previous state. When clear is 0, clock is applied. If load is given, you whether count can be anything, that at particular instant it will load the input. When load is 0 and count equal to 1, that is, then in that case it will do the normal counter operation, that is counting to the next value. Right, this is the present, this is the counter design. Okay, now assume that the counter gate delays are negligible. If the counter starts from 0, the cycle through the following sequences. What is the counter counting sequence is the question. If it starts from 0, when it will stop the counting? Chalo, try it. Give a try. What is the sequence? The counter counts you need to find. Time up. See here. Firstly, count equal to 1, load equal to 0, clock is applied. So count equal to 1, count 1, Load 0, clock applied. So the counter will do the job of counting next only. It will not do no change, it will not do clear, it will not do load input. So this input jo present here na, it is of no use, it will not read it. It will not read it. Okay, so the counter starts from 0. So it will read the load only when load input is given, but load input is 0 na, it will not read it. So the counter will start from 0, 1, 2, 3, 4. When 5 comes, what happens is you get 0, 1, 0, 1. When this and this both are ones, you get end input equal to 1. Then it will do clear. When clear is given, it will not wait for the next clock pulse. देखो ध्यान से, clear दिया तो immediately you have applied the clock or not, load or not, doesn't matter. Sorry. When clear is 1, the remaining all can be anything, it doesn't matter. तुरंत क्या करेगा sir? It will clear to 0. It will clear to 0. So what happens? 5 will immediately becomes 0. It will just come for a moment, but immediately it will make it 0. So what is the counting sequence is 0, 1, 2, 3, 4, 0. 0, 1, 2, 3, 4, 0 is the counting sequence. So let's move for the next question. Yeah, let's find some questions based on finding mod of the counter. Right. So let's start with this question. I already told yesterday 3 points to find the mod of the counter. We use the same thing here. First, identify the type of counter, up counter or a down counter, where it is a LSB, where it is MSB, find it, and identify the feedback gate. Is the process we used the same. You should use it here also. Right. Right. What is the gate you should use? Here, firstly, what is the counter you require? The mod 6 ripple counter is to be designed. So 0 to 5, when 6 comes, it should give the clear. 6 means what? Q2, Q1, Q0 must be 1, 0, 1, 1, 0. So you should give Q2, Q1 to a NAND gate and clear it. Why NAND gate? Because it is bubbled. Now Q2, Q1 ka jagah pe, wherever I applied the clock, that is the LSB. The second one ABC. So here I use A and B. You should use AB to a NAND gate. You take this bubble backside. This will also give you bubbled OR gate for A and B. So if I take A bar and B bar, I explained this in the class already. Then it will give you clear bar. If you take A bar and B bar, that will give you clear bar. So either you should use OR gate or NAND gate. If the inputs are AB, NAND, A bar, B bar, you should use OR gate only, because that here when both are ones, it should give 0. A, B are 1, 1. A bar, B bar 0, 0, it should give 0. Not only other gates may also give 0, but it should give 0 only for this case, only for both ones. So here the inputs are, wait. A is the LSB, na? A is the LSB, C is the MSB. Okay. Because A pe clock applied, na? Right. So here you observe B bar and C bar are given. So this gate must be OR gate. Got my point? Chalo, let's do the next question. Similar question to hi bhai. This one. AB, a similar question. So give a try. You need to find make a mod 6 counter of 3 flip-flops, a combination circuit of 2 flip-flops and 1 AND gate. Combination circuit of 3 flip-flops and combination circuit of 2 input AND gates. What is the combination circuit? 2 input gates. One AND gate is sufficient, one OR gate, 2 AND gates, 1 AND gate and 1 OR gate. Which one is the right answer? Right. Here it counts 0 to 6. When 7 comes, it should give clear. It can be Q2, Q1, Q0. When all of them are, what is it? Triple one, na? It should give me clear. It can be like this NAND gate, or you take Q2, Q1. Active high hai to maybe AND gate is sufficient. Or you can also do Q2 bar, Q1 bar, Q0 bar to an OR gate also, it is fine. But इसमें ध्यान से देखो, here NAND can be written as AND can be written as like this. Okay, because he said only 2 input gates. So this is the right answer. 2 AND gates are sufficient. Next, let's move. So a 3-bit. Here in the question, the frequency of the clock is equal to 1 gigahertz. So please try this question. What is the mod of the counter? Try करो, mod of the counter बताओ. Try please, try. This also we have discussed yesterday regarding how to find the modulus of the counter. Please give a try. Time up. Here, listen carefully. Firstly, whenever 110 comes, it will give clear. Fine. But what is the frequency of the clock? 1 gigahertz. What is the time period of the clock? 1 nanosecond. So here the delay of the NAND gate, the bubbled NAND gate is including the bubble. What is this? 2 nanoseconds. But 1 nanosecond is 1 clock, means how time period point of view it will take 2 clocks. You have given clear, but it is not going immediately. It will go after 2 clock pulses. So now see here. Q2, Q1, Q0, if you take all zeros, okay, if you take from all zeros to all ones, then right here it will count up to 6. Okay, that is at clock 0, 1, 2, 3, 4, 5, 6. Whenever 6 comes, it will clear. But a clear तो नहीं जा रहा है अंदर. क्यों नहीं जा रहा है सर? Because of the delay. Because of the delay, it will take 2 more clock pulses and it will do the clear. It will take 2 more clock pulses, and when it becomes in the 8th clock pulse, it will give the clear input to make it already 0 को 0 कर रहा है, because 6th clock pulse में मैंने clear input दिया, but it is having a delay of 2 clock pulses. 8th clock pulse पे जाएगा, but 8th clock pulse में already it is 0, so there is no use of the feedback. It will work like a mod 8 counter. Okay, चलो next question. Next question. Assume the clear input is synchronous. Find the modulus of the counter. ठीक है? Find the modulus of the counter. Please try this. Okay? Try this. Okay. Next. So here Q3, Q here, it should be 0, X naught, Q2, Q1, Q naught. 0, 0 is the first. Second clock pulse, it is 0, 0, 1, 0. Third clock pulse, it is 0, 0, 1, 1. Fourth clock pulse, it is 0, 1, 0, 0. Now please understand, when Q3, Q2 both are different, what do you get? It will give you clear input. Okay, but here synchronous clear na. Synchronous clear, don't clear it in the immediate clock pulse, it will clear in the next clock pulse. So it is a mod 4 counter. If it is a normal counter, maybe at 4 it clears, it is a, sorry, mod 5 counter, 0 to 4. Normal counter may it will clear at 4, 0 to 3 is mod 4 counter, but here it will clear at after 4th clock pulse. Okay, it will clear. So it is a mod 5 counter. Next. Let's do this question. These are little difficult questions compared to what we have done up to now. Little next level. Next level to understand, but once you understand, it is easy question. This is a 3 to 8 decoder. Up, down, counter, Q2, Q1, Q0, CBA with LSB is A. So Y0 bar, Y1 bar, this is a count down, count up, Q, Q bar, preset bar, okay. So try this question. Okay, Aryan, no problem. That's why I have taken the question. Why I have taken this question is you should commit the mistake, then you will remember better. So the circuit shown shows up-down counter working with a decoder and a flip-flop. Preset and clear are the of the flip-flop are asynchronous active low inputs. Okay. Then assuming the initial value of the counter is 0, the counter output after 12 clock pulses. Time up. Next, listen here. The circuit shown in the figure shows up-down counter working as a decoder and a flip-flop. Okay, for all the story is same. Here, when you give 1, it will down. When you give 0, this will be 1 and up. Okay. So here this is asynchronous. So clock and doesn't matter, only this preset and clear matters. This is asynchronous. But when you give the countdown input, this will immediately not down. It will work with clock only. This part is not asynchronous. Only this part is asynchronous. Be careful. So initially, when you start with all zeros, okay, your Q2 counter output. So the counter output is 0. Okay, when y0 is 0, it will go to what we call y0 is connected to clear. When it is clear is given, it will be 0 1. Clear is output is 0 and 1, it will be counting up. So 1 2 3 4 5 tak aayega. When 5 comes, this will go to preset. So it will give to preset diya to, then preset will make the D flip flop output 1 immediately, but the counter will not change it immediately. Counter will work with respect to clock, because this clock and these are here, we have not connected any preset and clear. Preset and clear are external here, so it will do down operation. So 4 3 2 1 0. Whenever 0 comes, again it will do the clear operation, that is up operation. So it is operating 0 1 2 3 4 5 4 3 2 1 0 2. This is the order it is doing. Okay. Just a minute. Just a minute. Next question. Consider the system shown in the figure below. Okay, this question might be lengthy. Okay, let's do this question, then we may go for that question. So, the square wave C1, wait, C1 in the figure given is the clock input to the 4-bit up down whose up and down bar. You have a counter which can do both up and operation and down operation. Up and down bar, down signal is given with bar complement. That is, when the up down signal is 1, it will do up. When it is 0, it will do down. With the pulse train PV. Okay, this is the C1 and PV. Okay, and the counter is negative edge triggered. The counter starts with all zeros. When will it reach 0 again? So this is a negative edge triggered. This is the negative edge of the clock. I am making the analysis easy so that you can understand better. This is how it is there for the clock: first clock, second clock, third clock, fourth, fifth, sixth. Similarly, 7, 8, maybe the ninth one will be like this. Okay, like that it will proceed. So please try when it will become 0 again. Time out. This may require little more time and more understanding. Okay, see here. The square wave C1 is shown in the figure is given to the clock input of a 4-bit binary. Firstly, what it will do, you should understand properly. Okay. So here, when up down bar, na, when this is 1 up, 0 down. So here it is up and again up, down operation. It is up, down operation. It is the pattern will be 2 times up, 1 time down. 2 times it is doing up. Let me check my writing is clear or not. Okay, it is visible. Perfect. So 2 बार up करके एक बार down करेगा ये. ठीक है. It is fed with a pulse train PV. So if you take the clocks 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. what is the output you get is 0. It will increase 2 times, then it will decrease. Increase 2 times, decrease. Increase 2 times, decrease. So you can see for every 3 clock pulses, okay, after 3 clock pulses, what is that? 1. After the next 3 clock pulses, 2. After the next 3 clock pulses, 3. Is it clear? It will increment by 1 after every 3 clock. Okay, increment by 1. So that 14 into 3, 42 clock. So 42 clock mein what is the output? 42 clock output is equal to 14. Then 43, 44, 45. What happens? Up, up, down. Up means increase, increase, decrease. So 15 will become 16 and again become 16, 15. So 16 is nothing but 0. 16 is nothing but 0. Okay? Right. No. ऐसा मत छोड़ना. सी क्वेश्चन बहुत लॉजिकल क्वेश्चंस ज़्यादा सॉल्व किया तो आपको व्हाट वी कॉल ज़्यादा कॉन्फिडेंस मिलेगा. एग्जाम पे ऐसे क्वेश्चंस तो आ सकते हैं, पीवाई क्यों है, ठीक है. सो बी केयरफुल, डोंट लीव द क्वेश्चंस ऐसा. इफ यू रीड द क्वेश्चन देयर इज नो डिफिकल्टी है ना इसमें, जस्ट एनालिसिस पार्ट है. देखो, सो बिकॉज you may think every 3 clock pulses it is becoming increment by 1 na sir. 16 3s 48 must be the answer na sir. Nahi, here you see after 9 clock pulses answer is 3, correct, but this 3 comes 4 clock pulse pehle also, but finally it will come at 9. Same way if you take after 6 clock pulses answer is 2, but it will come before also, but after 6 the final value will be 2, after 9 final value will be 3. That's why I have taken 14th value. Then after that, because 16 is very near to 14, so I started from 14. Instead of analyzing every single state, I skipped few states and directly I went to 42nd and then I analyzed. You can start with 36 clock, any clock according to your common sense. Okay, now it is clear, right? 16th is 100% wrong answer. 48 is also wrong, right? But when it is coming for the first is 44. Okay, 48 पे भी पक्का आएगा, बट इसके पहले 44 पे आ रहा है. चलो नेक्स्ट क्वेश्चन. ये तो आसान क्वेश्चन है. अभी तक हमने जो क्वेश्चंस किया ना, इससे सबसे आसान क्वेश्चन तो ये है. प्लीज ट्राई. राइट, लास्ट 5 seconds. चलो, ये तो आसान क्वेश्चन है. हियर वी अप्लाइड क्लॉक. इट इज ए 5 रिपल काउंटर, राइट? इट्स ए रिपल काउंटर, राइट? रिपल काउंटर में फर्स्ट आउटपुट, फर्स्टली हियर आई अप्लाइड द क्लॉक. वेर एवर यू अप्लाई द क्लॉक, दैट इज द what we call LSB, f by 2. This will be f by 4. This will be f by 8. This will be f upon 16. This will be f upon 32. Examiner को कौन सा चाहिए? Q3. Q3 is f by 16. So 10 power 6 by 16 is the answer. So 100, 1000 by 16 kilohertz. Tomorrow we start what we call data converters. So 62.5 kilohertz. Next question. So this is one of the important model we call pulse width measurement using what we call counters. So they can also come in your exam. There's one more pulse width question. I think one more question is there, that is missed or what we need to check. Just a minute. Somehow that is missed. Okay, we'll do that. There are different ways like frequency measurement using counter, pulse. They might be more important for EC people rather than electrical. So I'm not doing that. You can try this question. Time up. So a digital block in the figure is realized by two positive edge trigger. Positive बोला ना, ये options तो हटा दो. Then here first clock pulse I should get 1, बाकी clock pulses में 0. But if the D flip flop input is 1, whatever may be the remaining part, when you give clock, it will give you 1, 1, 1, 1 and so on 1. So this is not the right answer. So compulsory, obviously C must be your answer, but I will explain it. See here, initially here 1 is there. So initially what is the condition? Both the flip flops are at 0, 0. Here you have 1. Now, when you apply the first clock pulse, what happens here is this input will come here, this input will come here. Analyze from the right side, no confusion. So this is the change. So when you apply the second clock pulse हमने apply किया तो second वाला clock pulse apply किया तो now what is the input? 0 will come here. What is the input? 1 will come here. So it is permanent. Now onwards you give how many number of inputs? It will be same constant 0, constant 1. So output will be like this. So first clock pulse it will be 1, remaining all clock pulses it is 0. That is how you can design this particular circuit. Right? Chalo, next. Okay, let's do this question. Firstly, suppose there is a concept called pulse width measurement using counter. हम तो काउंटर यूज करके पल्स का विड्थ मेजर कर सकते हैं. Okay, how sir? Suppose this is the pulse of width TPW. Now I will allow the counter to count from here as long as the pulse is equal to 1. So it will stop. So how much it will count is equal to n times the time period of the clock. N times the time period of the clock. When it becomes 0, it will stop further counting. In this process, this is the error. Because clock start हुआ तो it will count up to the end. So what is the maximum error is, you may get 1 clock pulse. Right, fine. Now this is how you measure the, suppose pulse is given as, this is to be given as enable of the counter. Then it will count as long as the enable is equal to 1. So let's move now. See here. Try this question. Please try. Here, if you understand the question, you can answer it easily. The number of clock cycles for the duration of the input pulse is counted using the cascade connection of n decade counters. You have 1, 2, 3 like that, n decade counters are cascaded as shown in the figure. If the clock frequency is in megahertz, okay. So what it is doing, the number of clock cycles, the duration, the input pulse is 1. So the input pulse is measured as long as it 1, it will enable the decade counters, n decade counters. What is the mod of this available counter is 10 into 10 into 10 into 10 into 10, because cascade connection of n decade counters will give you 10 power n. Okay. So the examiner question is, if the frequency is in megahertz, the resolution and range of the measurement. Resolution is nothing but the smallest measurement it can do is 1 clock, that is 1 by f. What is the range is the maximum value of the measurement is how much it can count, 10 power n minus 1 times 1 time period. So the maximum it can count this much, minimum is you can count is, that is the width it can measure is minimum 1 clock, maximum 10 power n minus 1. So option B. It looks this much complex, but if you start, it is very easy. Okay. Probably the last question. So let's do this question and end the session for today. It is a master slave using D flip-flop. You check it, it can be used to convert the level triggered flip-flop into edge triggered. Okay, this question is also there. Okay, we'll do this. This is the final question for today. You have a 10 of digit time counter passes a base clock frequency of, this question comes under This you cannot do anyway. I will be explaining frequency measurement using counter. Okay, here it has a base clock frequency of 100 megahertz. When measuring a particular input, the reading obtained in the frequency mode of measurement with a gating time of 1 second. See here. So what is this frequency mode of measurement? First I will explain. Frequency mode of measurement. You take here, this is the gating circuit. इस केस में as simple as an AND gate can be used. ठीक है? And here we apply, this is the time period, unknown frequency signal. Here I apply gating pulse of 1 second. Now this is given to the clock of the counter with a display 10 and half digit, 10 full digits, 1 half digit. Half digit means LED display can display only 2 LEDs. Full digit can display all zeros to 9, all nines. Okay, so this is the counter. Suppose if you allow the counter with this clock, as long as for 1 second, if this becomes 0 and gate becomes 0, no clock will be allowed. If you allow it exactly for 1 second, what is the result? If you allow it exactly for 1 second, what is the result you will be getting? It is after 1 second, what is the result? The counter output is equal to the frequency of the signal, because the number of cycles in a 1 second is nothing but the frequency. So in 1 second, suppose it is counting N1 into Tc. So N1 is equal to 1 by Tc, that is the frequency of the unknown signal. This is the first information. Now he has done the same by using period mode of measurement with that 10 nanosecond scale with a base clock frequency of 100 megahertz. What is period mode? I will explain now. In the period mode, okay, here this is my gating circuit. Okay, this is the gating circuit. इसके अंदर कुछ भी हो सकते. It is not as simple as AND gate. Here we apply the gating pulse for exactly one time period of the unknown frequency. Tc is the time period of unknown, and here we apply the signal of known frequency. What is this? T is equal to 1 by 100 megahertz, that is 10 nanosecond. This is a known frequency signal, and now this is applied to the clock of the counter. Suppose it counts in one time period, that is it, I will allow the counter to count for 1 Tc with the clock of this one, that is it is equal to 1 Tc is equal to how much it is counted is, say for example N2 into T, and he also told the scale is in 10 nanoseconds now. So N2 into 10 nanosecond. Like if it is in a voltage scale, it is 23 volts. In 100 volts scale, it is 2300 volts. Similarly, if the counter output is N2, it is N2 into 10 nanosecond. Or in fact, you can also understand logically like this. In one time period, I am allowing the period mode mein, I will allow exactly for one time period, some other signal is given as the clock. But this frequency, I know it already. So in one time period is equal to, I will get some count here, that is I am taking as N2 times T. But examiner has, what is N2 here? N2 is equal to Tc by 10 power minus 8. So 10 power 8 Tc. Okay, this is your N2. What is N1? 1 by Tc. And examiner has given N1 is equal to N2. N1 is how much? 1 by Tc equal to 10 power 8 TC. So what is your TC? Or 1 by TC, because you take this 1 by TC square is 10 power 8 and 1 by TC is 10 power 4. That is the frequency. That is the frequency of the unknown. So what is the answer here? This is how we measure unknown signal frequency using counter. That's all. So we can end the class for today. लास्ट क्वेश्चन करेंगे तो सही होता है क्या? एनीवे मैं तो ये क्वेश्चन ऐड किया. ओके, ये सभी आप लोग ट्राई करो, कर होमवर्क ले लो. ये भी आपको भी प्रैक्टिस हो जाएगा, ये भी. ठीक है. See you then. We will meet tomorrow. So अभी तो अनअकैडमी पे ऑफर भी चल रहा है भाई, आप लोग तो सब्सक्रिप्शन लेना चाहिए तो सो डोंट डिले इट फर्दर. इफ यू हैव सिंक्रोनस सीक्वेंशियल सर्क्यूट्स तो कंप्लीट हो गया. सो ANT एग्जाम इज ऑन 29. दिस इज द लास्ट एग्जाम बिफोर योर मेरिन एग्जाम. So write this exam, learn many things. This here the questions are made by the top educators of Unacademy. You will be getting the questions. Okay. So see here. This is the offer going on. If anybody is a 24-25 batch students, they can take the subscription. They can use my code Shankar10. This is my code you can use. Okay, you get up to 30% off. This is available up to 28th. Okay, see you all then. Thank you. Good night. Bye bye. So last 2 classes are left. As I promised, within 20 hours we are completing our syllabus.